As the world becomes more aware as to the potential of additive manufacturing, I'm reminded of the situation back in the 70s when the first numerical controlled machines were introduced to a skeptical market. For decades, the CAM Auto had been providing lightning-quick turning capacity across all sectors. In comparison, the early, ponderously slow, single-turret, single-spindle NC machines left many an engineer scratching his head as to where things were headed. And whilst in many cases, cycle times have still not eclipsed those of the CAM Auto, in high labour rate economies, these machines are now nothing but museum pieces, a testament to the ingenuity of man. The same transitional processes are now happening within additive manufacturing, as it transforms into a viable economic alternative to subtractive machining. And this video seeks to tell that story. A story that describes the needs-driven journey of the rail sector giant Deutsche Bahn as it faced the difficult situation of an urgently needed part that was going to be delivered on a 10-month lead time through the normal process of casting and then subtractive processes. In this film, we have recreated that journey, documenting the processes undertaken and interviewing the decision makers who made it happen.
My name is Florenz Lichte. Together with a colleague, I'm managing the implementation of additive manufacturing at Deutsche Bahn. The secondary roll stop is a heavy steel component bolted underneath the car body of a frame. It's an operation-critical component that secures safe cornering of trains in tight curves. It's a part that we normally don't have on stock because it's not meant to be replaced during the regular maintenance schedule. But in this case, we had to fix an accident repair on our ICE fleet, and we had a demand of 2 parts. So we had to get them quickly. We got a quote from our supplier offering 4 parts minimum order quantity. But the downside was that we would have to wait 10 months for the casted part. And we would have to pay some serious money for the initial tooling costs. And you might imagine that was not an option for us. We had to reduce the downtime of the vehicle drastically to get it back into service quickly. And so we said, why don't we print this part? Why don't we use the Wire-Arc-Additive-Manufacturing technique to manufacture these 2 parts? And that's what we did. We set up a cooperation quite quickly with GEFERTEC and Wolf-Lenk, who manufactured the part. And in the end, we were able to prove that we could reduce the lead time of the part by 5 months. 5 months, and we could lower the total costs by 30%. Today we are progressing quite well. We've printed over 15,000 parts so far, 200 different parts, from small plastic parts up to 27 kilo steel parts like the secondary roll stop. So quite a progress.
Deutsche Bahn identified a part with a very small demand and approaches us if it's possible to realize this part in a 3D printing process instead of a conventional manufacturing process. Hello, my name is Tobias Kürnberg. I'm CEO of GEFERTEC. GEFERTEC is a Berlin-based technology company. Founded in 2015, we are focused on metal 3D printing by using WAAM technology, or as we call it, 3DMP. 3DMP stands for 3D metal printing, containing the CAM software, containing the process, containing the machine, and containing the quality management. The advantages of using 3DMP for a high-value metal part production is that you can reduce the cost of the entire produced parts, you can reduce lead time, and you can increase availability. And by doing this cooperation, we realized that we have here a real business case. So we grouped together with Deutsche Bahn, was focusing on the entire process, what is needed to bring this part into industrial usage. So that means the printing, the process from the technology side, but as well the qualification. And we did it very successfully.
I'm Kevin Hawley, Director at GOM UK. So GOM supply 3D scanning metrology equipment from manual systems through to fully automated systems. And in terms of component sizes, this can be from something small you'd hold in your hand through to complete car bodies, and all of those sizes of components are measured on a daily basis. So to create the scan data for a Deutsche Bahn part, we took the CAD model, we put it into our software where we've got what we call a virtual measuring room, so a virtual environment. And once we've placed that in the rotary table of the scan box, the software will take care of most of the hard work and create the scan positions for us. We received the component around lunchtime on the Friday, and for the WAAM part, I think the scan process was complete within an hour or so. If you've got some fantastic time savings from building your part on something like a GEFERTEC, then it makes sense not to waste any time further down the process. So by scanning, we can understand the part geometries and ensure that will clean up when it's being machined. For reverse engineering, if there were no CAD model available for a Deutsche Bahn part, that process in terms of data capture would be exactly the same as what we complete for the inspection of the WAAM part. So within 30 minutes to an hour, you would have all the scan data you need to reverse engineer that part from. The data that GOM supply Kingsbury will allow them to optimise the machining process on the Hermley, so avoiding any air cuts and ensuring that the net shape part produces a perfect finished machined part.
Hi, my name's Dan Castles and I'm Business Development Manager here at Kingsbury's for Automated Solutions. In this stage of the process, we take the 3D welded part and we set it up onto a 5-axis CNC machine. In this case, we're going to be putting on the Hermley C650. The initial phase of the process is to plan a method and program the part. By utilising the scanned image from the GOM machine at this stage, rather than a theoretical stock, we can optimise the tool paths to the exact form of the welded part. Therefore, we don't have to do any safety passes, or there's no chance of overloading the spindle on a heavy cut. The Hermley solution sits well with the whole process, so the GEFERTEC welds the part, then goes onto the GOM machine, which scans the geometry which has been welded. They then take that STL file and we load it into our CAM system and use that as our stock. There's no way of doing this without a 5-axis machine in one hit. The beauty about our machine is we have a slender spindle design and a very large A-axis range, which enables us to get into part geometries which are very tight to get into. The Hermley C650 is a perfect platform to machine the final stage of the Deutsche Bahn roll stop.
In the interview with Herr Lichter from Deutsche Bahn earlier in this film, he described how when faced with a 10-month lead time from their normal conventional route of supply, they looked at an alternative way of making this part. Their pursuit of a GEFERTEC solution effectively reduced that lead time, cut it in half. But it's important to note that this was the first time they'd gone down that route. So there was a lot of investigation and development and design of processes before they could realise the completed part. In this film, what we've tried to do is reproduce that journey. That's involved the filming of the part in 3 different locations. So we printed the part at the GEFERTEC facility in Berlin in a cycle time of 36 hours. We then shipped the part to the GOM facility in Coventry, where we did the scanning. And then finally, we brought that built part, now having scanned it, back to Gosport, where we machined it back to net shape on a Hermley 5-axis vertical machining center. The cycle time for the machining was around the 7-hour mark. So in reality, what was a 5-month process when it was done originally is now something that we could bring down to a matter of days. Wire-Arc-Additive-Manufacturing, or WAAM, allows for the rapid deposition of material in the building process. It takes place within a machine that is kinematically arranged around 3 or 5 axes, depending on specification, all of which is controlled by a Siemens 840D controller. The raw material used is standard welding coil. An important point to emphasize. Arc welding was first developed in the 19th century. We all rely on it in our everyday lives, be it in the car that we drive, or as we have seen, the train that we commute with. It is a fully understood and accepted manufacturing process, and because the raw material is welding coil, as opposed to metal powder, does not require the same health and safety precautions associated with a powder bed fusion machine. If your current processes involve the lengthy lead time of hard-to-machine material, be it cast, forged or billeted, then this solution from GEFERTEC may prove to be an interesting commercial alternative. We hope you have enjoyed this video and that the insight that we have given you provides an idea of how the GEFERTEC solution could be a commercial option worth considering. Many thanks for your attention.